All right, so we are on Module 5 today. Module 5, we are going over the for statement and the if. We're also going to be going over functions if you haven't really seen them. Or rather, start really writing functions as part of solving our problems. So I'll be starting to organize our code by putting it into functions. Make sense? Make sense? So today I said on Tuesday, I'll be reviewing some problems I do as homework. Said on Thursday we'll do exam review. Instead, on Thursday, we'll be doing one of my most infamous things that I used to give as homework, but we'll be doing it as an in-class exercise, which is blame Pope Gregory the 13th. Because our exams aren't until late next week / the week after that, I'm not going to, I can't, it doesn't make sense to review. But what we will do is so here, loops, done in class. What is today? The 11th. Edit. On 11/2. Save. And then what we'll do here is we will go to here. I will go to Documents, GitHub, Teaching. I'll go to Intro, Exam and Practice. I'll be sending this out later this week after I modify it a bit, so you guys can get an idea of what my exams look like. I feel this is especially important for Intro to Computer Science classes because a lot of you, this being your first programming class, will have never seen what a science exams looks like. And if you've been in a computer science class before, you've never seen what one of Professor Rosen's computer science exams look like, which is a different beast altogether. Not in a bad way, but just simply, it's always unfamiliar when you go into a different professors. The practice exam I give here is much longer than the actual exam because I feel more practice is better. I give yourself 2 hours to do it because that's about the amount of time you have in the lab. Also, there are a bunch of questions in here that have 0 points assigned to them. Those aren't. If you're timing yourself for how long it's taking, ignore the 0 point questions as you're going through because those are simply set up as extra practice. Okay. So one of the things you should know, especially about these classes, is that the space I give you for a problem does not correspond to the difficulty of that problem. That corresponds to me predicting messy handwriting or erasures, right? Or just simply organizing things or organizing the page. So don't base your answer, the length of your answer or the difficulty, your perceived difficulty of a problem by the amount of space I give it. The indicator for difficulty is going to be the number of points that question is worth. Make sense? Yeah, so you're allowed to clarify any answer you give. You're allowed to answer any clarification. One of my friends was very fond of saying all questions are essay questions, including the multiple choices. In other words, if you feel like that the question is malformed or not correctly stated, you can basically write your assumptions. And you should know by now I'm a fairly reasonable guy, and if your assumptions make sense, yeah, and that leads you to a different answer, sure. This is very rare, but it does happen. I will give, on the back of this first page, basically a cheat sheet. On the exam, you're allowed a cheat sheet, a single page of paper, front and back. What size of the paper, and whether it can be handwritten or typed. I don't care if it's handwritten or typed, and as long as the paper isn't interfering with your colleagues taking their exam, it can be whatever size you need it to be. So probably no poster board because, again, that would probably be slapping the people in either seat next to you. So it'd be a bit unwieldy. But honestly, whatever size you want to make it in terms of or however you want to make it, using handwriting or using, using handwriting or using type, that's good. One other thing I should mention, because it's rather new, right? I know that a bunch of you have probably gone to ChatGPT or whatever for, getting help on homework or something. Not great, because you got to make sure you got to be able to answer it yourself. But here's some great advice of what you can use AI for. Because again, it's a tool. So I should instruct you in the best way to use that tool rather than saying don't use it. If you use it to just do the homework for you, you're not going to get anything really out of the homework. And last I checked also, it's pretty trash at doing turtles and other graphical stuff, because like trying to tell it to draw specific shapes can be rather difficult for it, because that's just not what it's built for, at least at the moment. That can change very rapidly. What I would recommend using ChatGPT for, especially with regard to this practice exam, is feeding it some questions that you have difficulty on and asking for variations on this question, or questions that are similar. Have it generate practice problems for you. That's a pretty good way of doing that. Similarly, if you've got an answer and you aren't quite sure how you got there, asking it to explain those answers. Those are good uses of it. But again, using it to kind of not spend the time to practice, that's where you're going to really get into trouble with it. Also, because ChatGPT is basically, in terms of code base, it's grabbing a lot of code from the internet, from public GitHubs and stuff like that. It's going to be using some more advanced Python techniques than you probably than I go over in class, and that can be a real hurdle, especially when you have to come to me to demo your work. So, that's just there. In the event that you do forget to do a practice, that you do forget to give me that you do forget to bring a cheat sheet, and you don't have to turn it in or anything. You don't really. That's fine. In the event you do forget to bring in a cheat sheet, I use this back page to basically have my own cheat sheet, right, with a few notes and stuff like that, just to kind of remind you of a few things you may have missed. And you'll be able to go through it. There's going to be less questions on the actual exam. This is specifically meant to be intimidatingly long, just so that you can get plenty of practice on it, because I believe that the practice exam should always be harder than the actual exam itself. And then at the back, I have even more questions for practice. And if you're able to get through a bunch of these questions, then you're probably in good shape. For this one, Google that. So if you aren't sure what it is, if you want to figure out what that is. All right. So again, I will be sending this out either today or Thursday. I generally give it a week in advance. That means that also that since our exams are on the 21st and the 24th, okay? That means that I'll issue this practice exam, and then I'll probably do the review on the 20th. Okay? I'll take a look at the calendar. It will either be on the 20th or the 18th when I go over these problems in class. Okay? The last thing I should state is what to do if you're sick or whatnot. My general policy is that we try to do accomplish makeups. I do try to do makeups on these things. Last semester I started giving a third exam as kind of a makeup exam. I'm not sure what policy I want to use yet, because I typically just tell my TAs to handle it. But here's the long and short of it. I think I'm going to do for this semester. If you need to make up the exam because you missed it because of illness or something happened, you need to make it up before the start of spring break, okay? If you don't make it up before the start of spring break, it's going to be a 0. But I'm going to give three exams and a final. So if there's something that completely incapacitates you, that you can't get to the exam in time, there's going to be 3 exams plus the final. Of those 3 exams, I'll be dropping the lowest score, right? So that will mean that basically that if you miss the exam, you can either try to make it up, or if you can't make it up in time, that's what the third exam is for. Make sense? So, because I did have issues with students who would come to me like 2 weeks after and say, hey, can I make up the exam now? I'm like, but we've moved on. You've had more time to study this. It's not really fair at this point, right? 1 week is kind of fair, especially if you've been sick, but 2 weeks, that's no. So it's just trying to balance this out. If you're sick, again, just send us an email. Don't come. We probably won't need a doctor's note for that unless it goes past that week. So if you have like a car, incident, let me know. If you get called up at 4 o'clock in the morning and you're told that a family member has passed away, don't sleepwalk your way into the exam at 9 a.m. True story, this has happened to a student, because I can't accurately assess the exam at that point. So, just send us an email, tell us what's going on, stay home. Okay? I want to help you as much as possible. All right. Let's see. So I will be doing a quiz this week. The quiz will be over for loops with turtles. It will be something very similar to, but much easier than what you're going to see on the exams, which is, hey, here's some code that has a for loop in it that draws something that tells the turtle to do something. Draw it, please. Right? So that's kind of what you're looking at. Again, there's going to be a number of those things on the exam. Okay. Let's go ahead and start up with our function and loop exercises. So hopefully you've started taking a look at your exercises. At your homework, right? That was given out on Friday and on Monday, correct? Right. This lab 4 and 5. This used to be what was the follow-up homework to that. And I'd give it out around the same time as the exam, but because of the way I've modified the exercises and turned lab 4 and 5 into like a double assignment, this has now become transferred into an in-class assignment. So so here we're going to use this to kind of go over what the return statement is versus the print statement, as well as kind of go over some things that we can use for a for loop. We're going to see that even basic problems have a number of valid solutions, and the more comfortable you get with, and you'll see that the more comfortable you get with the syntax, the more practice you get with the syntax, the easier a bunch of these become. Right? So the first problem is going to be number of vowels, which is a function. We're going to write a function, a new verb, given a string, returns the total numbers of vowels that were in the string. That means you need to feed the function you write a string as a parameter and return an integer. Okay? So what do we do? So first things first, when we write a function, let's go ahead and save this. Save as, and we are going to go to Documents, GitHub, Classroom, Intro 2.11. Okay. So to write we're writing a function that tells us the number of vowels. The first thing we need to do is we need to write the def keyword when we are creating a new function to define this new verb, this new action that a programming language can perform. Then we need to give it a name. Okay? The name is we want to give it a meaningful name to remind us what we're doing. This is to count the number of vowels in a string, so I'm going to call it num vowels, right? Just like that. Once I'm done naming it, I use parentheses, to indicate what the parameters of this are going to be, what arguments it's going to have, and then a colon to say, hey, we're going to have an indent. I typically put right over here, I'm putting a pass. That is a placeholder. This basically means this line is empty. You should never have a pass in your finished product. This is just simply, hey, I need to put something in here to satisfy the indent while I'm thinking. So let's think about what this problem takes in. This problem says it takes in a string, and we want to count the number of vowels in this string. So we're taking in one thing, which means we stick one thing in the parentheses. That is text, right? And you'll see I'm not really going to make you write too many functions in the practice exam when we go through it. Right, when I go through it, I typically have functions that are written for some of the questions, but I don't, and I tell you to complete them, but I don't have you declare them. Make sense? So here, def num vowels text. So this says I'm going to take in some string. Text is a great name for string because because a string is a bunch of text. Okay. So what this needs to do is count the number of vowels. So I'm going to just go ahead and create a variable called count. How many I've counted so far at the beginning of this program? 0. Right? We'll get to the returning at the end. Typically what I would do now is I'd basically define, okay, since this is my answer, I'd return count. This is typically what I do. But since I'm going to use it to review what returning is / introduce it for the students who've missed it, I'm going to just kind of leave it blank. I'm just going to ignore that for now. I'm just telling you what I would normally do. And now I can work on the problem. So I want to count the number of vowels that occur in text. So there's a couple different ways. There's actually a ton of different ways to go about doing this. Kind of the most obvious that springs to mind is basically the way that all the algorithms are going to work, which is we need to go through this text letter by letter, or character by character, or glyph by glyph, symbol by symbol. Look through that and say, hey, is this, for every character in this, if this symbol is what I'm looking for, then if this symbol is a vowel, then add the count. The other way you could do it that does not use for loops is that you could because there's so many ways to do it, is you could do you could use count is equal to text.count, which is the count function inside of that. Right? And then just copy paste this for all 5 of the vowels, right? A, E, I, O, U, right? Makes sense to everybody? I could do that to get the answer, but let's go through with the for loop solution, which will probably look like something, and I'll start you off on that. For car in text, for every character in text. And there's multiple ways to do it. You can add something over here to help you, or you can just go straight into there. But you'll need an if statement to do this. And the idea here is if, and then you have a truth or false, a Boolean statement, right? Hopefully you've taken a look at that, the if statements. If this is true or false, if this is true, what is true? Well, what we're looking for, which is if this is a vowel. So if this is a vowel, then we want to increment count is equal to count plus 1. Make sense? And then we can print our count to kind of confirm to our eyes that this is working. All right, so take a few moments to figure out, hey, what can I put here? And like I said, there's multiple ways to do this. Some of them are way simpler than others, but this one is, but there's a number of really good ways to do this. If you're having trouble with this, I would start out just simply targeting small. Just simply count the number of A's that occur. So that if statement would become if that character is an A, right? Right, and it's going to just be kind of some longer statement over here. I'll go around. If you have more if statements, this is going to be a great introduction to it. That's fine. Sorry, no. Now, what you can do is you can do multiple conditions by saying, or if it's like the character is B, sorry, not B, or if it's this. Right? So I'm going to go ahead and get people started, but I'm not going to finish this yet because I see a lot of people are stuck here. So to check if something is true, so what we do over here to go back to checking the number of A's is we would ask something like this. If character equals A. And what the double equal sign does is that it asks, are these two things on the side of the equal sign the same? Right? It's asking us to, hey, if these were numbers, this would be our testing, are these two things the same value? Here we're testing, are these two letters the same? And so here we're saying if character is equal to A. Now, the key here is that you could, now knowing this, you could actually figure out, oh, how would I do all of these? How would you make all of these? Well, I would just simply do multiple if statements, right? Like that, like I did earlier kind of with the count, right? And just simply say, hey, if it's an A, if it's an E, if it's an I, right? That's one way to do this problem. Make sense? So this if statement checks for equality. And again, what does this mean? An if statement, it says that the line or lines inside an if statement will only execute if this evaluates to true. So if this is, for instance, aloha, right? On the first A in aloha, it will say, this is true, increase count by 1. And then in the second A in aloha at the end, it will increase it by 1 again. Num vowels aloha, right? But of course, this isn't the number of vowels in aloha. This is just simply the number of A's. Aloha has 3 vowels in it. And this gives us the number of A's, which is 2. The other way we can do this, another way we can do this, I should say, or the way we can make, if we're doing this if statements with equal signs, the other way we have to do this is with the or statement. So this is what we call a Boolean expression. A Boolean, which means, and those are the kind of things that we would have that evaluate to true or false, right? This comes down to a true or false. A Boolean expression might be, hey, is 5 equal to 6? No. Is 5 equal to 5? is 5 equal to the absolute value of -5? -5, not -1, Andrew. There you go, right? Absolute value, remember, just simply gets rid of the negative signs. Oversimplified math, but yeah. So what we're going to do here is we are going to, we can also, again, other Boolean statements include, hey, is A less than C? True. Why is that true? Because it comes first and alphabetically. So that's how it ranks letters, right? So the Boolean statement, so you already know pretty much those Boolean operators that we really care about, which are, because you've been using them in math your entire math education. Equals, to check our two sides equals. Well, double equals in computer science. Then we have less than, we have greater than, we have less than or equal to, and we have greater than or equal. Yeah, greater than or equal to. Here we go. So you already know those. Most common we're going to use is double equals, though, to check are two things equal. There's some other ones we'll know about that I'll get into as we continue with this problem. The other thing to know is that you can chain multiple expressions together using two keywords, and or. And says, hey, I've got two conditions, x and y. Both x and y have to be true for this entire thing to be true. For this problem, that's not really relevant. Make sense, though? Both sides of this has to be true. For this one, x or y, this one is one of the things has to be true, right? If x is true or y is true or both of them are true, right, then the entire thing is true. Make sense? So here, you could ask if the character is in A, or if the character is in E, or if the character is in O. And it gets a bit long, but you get the idea, right? So go ahead and try now taking a few more minutes to complete this. And then we will go over this in a few different ways. Right? Specifically, right? So you see something like this. If A equals, whoops, A equals B, or 5 is greater than 2. Right? That would be a true statement. So let's go ahead and get this one. So walking around, I saw a lot of you make a very, very completely understandable syntactical error, and it's not going to throw a what makes this one annoying is that Python's not going to tell you it's wrong. It's just going to still run, and you're just going to get a wrong answer, which is if you do, but you want to do, because you want to be able to do this. If character equals A or E or I or O or U, because you really want to be able to say, hey, if it's one of the selection of these. We're going to come back to that, and we're going to do that in a bit. But you really want to be able to see this, to do this. And if you run this, right, it's going to run, but it should give us the wrong answer now, which is it's going to tell us there's 5 vowels in aloha, which that can only be true if this is true every single time. So it's mistaking everything as for being a vowel. Now, why is this? This comes down to something that Python can annoyingly do called truthiness, which I'll demonstrate very clearly right now. If 1, 5. If 0. It's something that's nice when you know to look for it and know to do it, but otherwise it can be a real pain when you're just teaching this. Truthiness, so Stephen Colbert used to have a show called The Colbert Report, and before that he was a correspondent on The Daily Show, and in his first episode of The Colbert Report, he coined a term called truthiness, which is that things aren't necessarily true, they just have to feel true. And truthiness applies here in the sense that these variables feel like they're a true or a false, or these values feel like they're a true or false. And the way Python determines that is, it figures if Python says if it's not a 0, it's true. If it's a 0 and if it's a value that's a 0, it's a false. So that's the rule there. So what do I mean by that? Well, let's go ahead and see. -1 is going to be a true. 0 is a false. So and effectively what I'm saying, if true or if false here. So it's always going to be the same answer. So 0, that's falsy as opposed to truthy. Now this applies to strings as well. If apple, it's looking for a Boolean expression and it sees a string and it's like, well, let's just figure out what kind of, is that a truthy or falsy? It's a truthy thing. So it goes 5. So it's true for all of them. What is a 0 for a string? It's an empty string. Right? Same with an empty list. So it's a good way to check. So why is this? It's a good way to check if something's 0 or not, or if it's empty or not. Personally, I like to just simply be straightforward and say if the length is something. It's not necessarily a feature I like, but I don't have to like every. But Bjorn Strusup said the inventor of C++, said there's only 2 types of languages: the languages people complain about and the languages that nobody use. So, yeah, every language has its own quirks. So as a result, basically it's saying it checks if it's, for the first letter, it checks, okay, is character is equal to A. It is A, so increment count by 1. Then it says if character is equal to if L is equal to A. Well, L is not equal to A, so we're going to check the next statement. Oh, the next statement's an E. I guess that's true. I guess E exists, so that's true. So and because one thing is true, the entire thing is true. So what you're looking for, and what we really mean or what we intend in Python syntax is this. If character is equal to A, E, or if character is equal to E, or character is equal to I, or character is equal to U. Now, that being said, there's better ways to do this in Python. Why am I doing it this way? Because when you get to another programming language, this is often the way you have to do it, right? Which is a compound if statement. In Java, I pretty much have to write it like that. I'd basically be saying in Java, if C is equal to A, and then I would use 2 bars in Java. Or if C is equal to, and I think the or is the reason this occurs, the word or as opposed to using a symbol for or, because it just feels like it's English, and so you should be able to express it like English. So this is where Python's being too awesome getting in the way there. So this is way number 1 of printing this out, right? I said to return it, and we're going to get there in a minute, but what's another way we can do this one? Well, what we really were looking for was saying if character is any of these. And there is a third statement we can use to do that. We have and we have or for kind of creating compound statements, but there's one more, so I guess it would be a 6th Boolean operator that we can use. So right, the Boolean operators being less than, greater than, equal to, less than or equal to, greater than or equal to, and then we've got one, and then we've got another one. There's a few more, but they're not really too relevant, and it's the word in. For those of you who are coming from a heavy math background, this is the math subset operation. Saying basically asking if A is a subset of B. But we just simply say in, because grammatically it makes sense. Let's go ahead and see how that's used in practice. So if 5, this is a Boolean statement. It's asking a question. Is 5 in 1, 2, 3? No, it's not. If 5 is in, 5, 2, 1, 7. 5 is in 5, 2, 1, 7. Right? If 5 is in 1, 5, 2, 5, 7, it doesn't matter. Write that, and let's go ahead and just simply change this up. If 5 is in negative 5, 1, negative 5, 2, 1, 7, right? 5 is negative 5, so it's on there. You can also, and of course, if you can use this for lists, you can use this for strings, right? If bat, so we can ask if bat is in Batman, that's true. Make sense? So, in this case, we have a way to really simplify this one, right? So I'm just going to simply copy this, and I'm going to call it numvals2, right? Because you can't have 2 functions named the same thing if you want to be able to use them, right? So what we're going to do here is I'm going to use this space that we left empty up here. I'm going to say vowels. I'm going to list out my vowels. Vowels are equal to A, E, I, O, U. You could also do it as a list. And then I can ask for character in the text, if character in vowels. Make sense to everybody? If character in vowels. Okay? And then it will say, and then it will increment the count. So let's go ahead and run both our programs. 3, and let's actually not, let's go ahead and run them both. 3 and 3. So AEIOU, and then this checks, hey, if the character is in AEIOU. In fact, we could potentially just skip this and say, hey, if character is in AEIOU, but this can look very efficient to some people and very ugly to other people, right? So again, I personally like doing it like this. Okay, we have one last issue, which is, of course, as follows. This, which is if I make it aloha, capital A, aloha, right? That's going to return 2 vowels, even though there's 3 in there. Why? Because it's case sensitive. Now, we have 2 ways of dealing with this. The first way makes you groan if you did it this way, and still makes you mildly miffed if you did the other way, right? Which is what? You then add or a character is equal to, oh, there's 10 vowels now instead of, and this gets very long, obviously. This is annoying, but it's a valid way to do it. And if it gets the problem done, it gets the problem done, right? That's for an exam, that's what matters. For here, we would just simply, this one, it'd be slightly shorter, A-E-I-O-U. A-E-I-O-U. So the other way to do this is to say, I'm only looking for lowercase letters, okay? So what I'll do over here is I'll say text is equal to text.lower. I'm going to convert I'm going to convert this text into lowercase. That's what lower does. It converts it into lowercase, and then I'm just going to run it. That way, even though it says aloha, I'm still getting 3 and 3. All right, on to returning. So this serves as input. So the parameters, the arguments, they serve as inputs for our functions. They basically serve as a way to put things into a function. The returns serve as a way to get something out of the function. Now you might be thinking, printing the number gets something out of a function because I can see it. But what I'm saying there is not really no, because we have count here and we are printing count, but printing something just displays it to the user. And that's really nice for us programmers. But it does not provide this. But if I needed to use this number somewhere else in another equation or something, this does not provide me with a way to use that. So basically, a lot of the way the forms of this goes is that return gives you the answer to whatever the question the function is asking. Num vowels asks how many vowels are there, and returning the count gives the answer back. Now, the key here is that once you'll see that if I replace these with return statements and I run it, we get no answer because it just returns it. And so this basically gets converted into 3, and then we don't do anything with it, right? Although if I stored this variable in x, right, if I said, hey, x is equal to num vowels aloha, I ran it, and then I queried, and this is one of those great things you can do with idle because of the way it's structured. You can actually query the Python script that just ran and ask, hey, what are things right now? And it says x is equal to 3. What this did, returning, is that it replaced this function call. When the function call gets an answer, it replaces the function call in the equation with that answer. So here, the num vowels aloha, that calculated it as 3, and it replaced the function call with the return value. Whoops. There we go. And again, x. So how do we handle this? If you want to just print these values out, you just print out the function call at that point, right? Which can be a bit annoying, but it allows us to be more versatile. It allows us to reuse these things. It allows us to avoid extraneous outputs. And you'll see these when we really start chaining functions together or breaking our program into multiple parts. Okay. Now, let's go ahead and go on to, let's see, another problem. I think I have 4 here, so I do need to speed this up. Second question is, worst case scenario, we'll just do the first, we'll do 1, then we'll do 2, and then we're going to do 4 if we need to, and then we can come back to Armstrong numbers if we need to. So the number of even digits. So very similar here, only we're dealing with numbers. Write a function which, given an integer, returns the number of even digits in an int. For example, if a function is passed the number 254, it should return 2 because two of the digits are even. Specifically, 2 is even, 4 is even. So you will need to use modulus and division to solve the problem. Technically, you don't need to use division, but it does help a lot. These strategies he used here will help you develop solutions for the next two problems, right? So, and why do I say that? Because we run into a bit of trouble here. Num even digits. We take in a number, right? And your first instinct is to write something like is to do this, right? This part is correct. Digit, or we can put count over here to make it exactly like the other one. Count is equal to 0, and then we're going to return our count, right? Often I often define what the accumulator, if I know we're going to be counting something, I often define that value and then return it and then put my answer in between, right? Or put the rest of the code in between. Okay? And so your first instinct is to do, in Python, is to do this. For digit in number, right? To go through every digit, and we can just simply print to make sure that, to see that that works. All right? And then we run it, and you'll be like, oh, nothing happens. What? Oh, right, because I forgot to call this. This happens all the time. This was actually intentional on my part, but this happens all the time. It's like you write something, why does it run? Right, because they didn't call the function. Make sense? Very, very common. Num, even, digits. So we're going to call this not equals. We're going to give it a number. We're going to give it 1, 2, 3, 4. We're going to give it the value 1, 2, 3, 4, and we're going to say our answer is n is equal to the number of e's in digits, and then we're going to print out n. Okay, now we're going to run it, and it will crash. And if you play Magic the Gathering, you'll know a phrase possibly that where we say reading the card explains the card, which sometimes that's not true because those cards can be complicated. But in this case, in Python, at least at the beginning, reading the error explains the error many of the times. Although then you have to figure out sometimes what that means, right? Here, the error says, hey, it tells you it occurred on line 27. Line 27 when you call, it was triggered by line 27, which called a function, and that function, it ran into an error on line 22. 4-digit in number is the line where it says that's what gave us issues. And the error was a type error, meaning that it was the wrong type for something. Int object is not iterable. It's saying, hey, this thing over here, this integer over here, that's a number. You can't iterate over a number, right? Now instinctively you'd think, but I want to iterate over the number and I want to go left to right. It's kind of obvious as to what I want to do. So there's a couple ways to do this. Using the tools that you currently know now, you kind of have an idea of how to do it, which is we just transform it into something we can iterate over. Makes sense? This is personally, I feel, the wrong way to do it, but it's also the way you know how to do it, right? Being from a mathy background, there's a numerical way to do it, but I'm biased. And the answer is that you want to get an answer that works. So the answer there is you convert that number into a string, right? And then you can iterate over a string. Make sense? Yes?
What is iterating over something?
Iterating over something is to go through item by item. It's to loop through it.
Why would I start with
Because you can only loop through sequences. Sequences are lists, and right now the sequences you know are lists and strings. You can't. You can only loop through things that are collections of other things. A number isn't defined as a collection of digits. It's just defined as a number. Make sense? A number So here we're turning it into a collection of individual characters that we could loop through. Okay? And like I said, because we're running, because I want to make sure I have enough time, I'm just going to walk you through each of these. So 4-digit in string number. So, great. Now, one of the things you have to do, though, is that now we need to check, is this an even digit? Now, there's a couple ways you could do this. We could write, it's going to need an if statement to check if it's an even digit. And you could first, let's get to our first issue kind of naturally. We'll create our first error naturally by kind of doing a as above, so below, right? The idea here is, okay, I check to see if each of these are digits are, each of these characters are a vowel. So I'll check every digit to see if it's one of the 5 even digits, right? If digit equals 2 or digit equals 4. And I'm going to stop myself right there. Plus equals count plus equals 1 to increment count by 1. And then we will go ahead and run this. And we will get another, a 0? A 0? Why'd we get a 0? Well, let's go ahead and sorry, 1 second. Print digit equals. Sometimes if an if statement isn't triggering, you might want to check. Wait, what's the comparison I'm doing here? If digit equals 2. False, 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 false. Okay, we know we had a 2 in there. The issue is that I wrote the number 2 over here, but over here, right, what did I say? We're going to convert this into a string because I can iterate over a string, and a string is composed of other smaller strings. So even though I want to treat it as a number, what is it? It's a digit. This digit is a string still. This is where suddenly that I say this approach is not great, because you either have to do this, right? Or more correctly, more efficiently, we can do digit is equal to convert it back into a, so we take that into a number, and then we take each string and convert it back into a number. Two or 4 or digit is equal to 6. And while this gives us an answer, it's not really satisfying in my opinion, because we're not really testing to see if a number is even or odd, and that's a useful skill. The way to test if an even number, how do I know if a number is even or odd, by the way? Right? Yeah. Yeah, if it's equal to, if it's divisible by 2, right? Yeah, it's 2n. If it's a multiple of 2, if it can be expressed as a multiple of 2n is what you're saying, which I like to refer to, and more relevant for our discussion, if it's divisible by 2, cleanly divisible by 2, because if you want to be if it's cleanly divisible by 2, it is an even number. Right? If it's not divisible by 2, it's an odd number. How do you know if something is divisible by 2? Well, as you could say, as you mentioned, if it can be expressed as 2n, but the other way you can look at it is if you divide this number by 2 and you have no remainder, then it's even. Make sense? And the reason I put in that phrasing, if you divide by 2 and it has no remainder, it's even, is because we can test if something can be divided by 2 and has no remainder, right? We can take a number. Let's go ahead and say our number over here. Number is equal to 1, 2, 3, 4. Let's go with a different number. 2, 2, 4, 4. Feels like a very even number to me. We can divide that number by 2 using integer division. We can also get the remainder of that number after it's been divided by, when it's divided by 2, right? Which is, because this is an even number, it's 0, right? This is a large number, right? And again, division with very large numbers, right? But you can kind of look at a number, but you can easily look at a number, ask if it's even or odd by just looking at that last digit, right? Mod 2, right? We know this has a remainder of 0. So it's an even number. So we can do this test then. We can ask ourselves if digit mod 2 equals 0. This is a very common operation. The most common you're going to see is if a number mod by 2 is equal to 0. Why is this? Because you can often use this to kind of flip a switch, right? If it's odd, it should do one thing. If it's even, it should do another thing. And we can alternate between even and odd states. Very common operation there. Another thing we can do, and the other common one is mod by 10, as we'll see in a bit. But if digit mod 2 is equal to 0, count plus equals 1. This says, hey, if we take this digit, divide by 2, and get 0 as a remainder, that means there is no remainder. If there's no remainder when you divide by 2, it's even. It's the definition, or it's a definition. So here we can do 1, 2, 3, 4, and this will tell us there are 2 digits in here. We'll do, let's go with 4, 2, 2, 2, 6, 2, 6, 2, 8, 4, and you'll see that there is 1, 2, 3, 4, 5, 6, 7, 8, however many keys I pressed there, which is 11. Right, and it'll tell you, there's 11 digits here. Now, this is easy to do in Python because this specific way of doing it in Python is easy to do in Python because we just simply kind of converted it kind of very naturally, right? We just simply tossed it. To convert it to a string, we tossed it into a string, and then to convert each individual string back into a digit, into a number, we just tossed it in the int function. However, other programming languages, that takes a few more keystrokes sometimes. As I mentioned, this was not a satisfying way to do this. The other way to do this, which is kind of the more efficient way to do it because because converting can be expensive, is to do it like this. We still use this base if statement inside here to increment the count. This part does not change because this is like the core kind of decision here. What changes is how we go through this problem. And in this case, we're going to use a while loop. Now, while loops are a lot like if statements. They execute only if they're true, but they keep executing while they are true. So why is this relevant here? Well, what I can do is I can set up a condition like this. While number is greater than 0. Why am I doing it like this? Because I'm going to go through each of these, because I'm going to go through this number and count each of the digits. And then, well, I'll just kind of show you and then I'll explain. This is one of those easier to see than explain than to just kind of get there, at least with the amount of time we currently have. So while number is greater than 0, I'm going to say digit, because we don't have that defined yet, is equal to number mod 10. Okay, what does that do for us? Why mod 10? What in the world? So what we're going to do over here is that when you have something like this, a big number like this, oh man, this sounds like a great thing to put on a quiz. If you mod it by 10, right, the math might look hard because I'm dealing with giant numbers, possibly even gianter numbers, right? But modding by 10 asks what? What's the remainder of this number after it's divided by 10? 4, right? And that's easy to figure out because what's going to be left over after after any number is divided by 10? It's the ones place, right? So, right, if you divide something simple like 24 mod 10 if you divide this by 10, right, you go into the 20 twice, and then you have a remainder of 4. On the flip side, so the trick here is that you can, when you mod something by 10, you're effectively asking, what is the last digit of this number? So this grabs the rightmost digit of the number and asks, is that number divisible by 2? And if so, increment the count. Now, if I were to run this, I'd be running into a bit of an issue. And in fact, I will run it because that sounds funny to me. 2, 2, to give them, and I'll get into, this created an infinite loop. Why? Because I get the last digit of number and test if it's even. And while number's greater than 0, well, number's still greater than 0, so I keep doing it and doing it and doing it again. While loops are a bit easier to create infinite loops in Python. While loops are basically your primary way of creating infinite loops in Python. So what I have to do is, well, if I get this, say I'm trying to calculate the number of even digits in this, and I'm getting the last digit, then what I should do after I'm done with that last digit is I should get rid of it. So we're going to look at these math operations instead of as like pure math operations, as kind of like manipulations. When you divide a number by 10, you're effectively throwing away the last digit, right? Let's go ahead and, so I'll run this to kind of show that it works. And then I will, let's see, oh, no, digit, sorry, number. I mistyped. That was another infinite loop, oops. Talking and typing is harder than it looks. Number is equal to number divided by 10. There we go. I wasn't modifying number, did digit. See, that's a common mistake that you would make, and I made it. I make mistakes like this all the time. The difference is that I've made this mistake so much that I kind of spot it and I'm able to fix it as soon as it occurs. That's the big difference as to why I'm able to fix mistakes. Not that I'm any better at avoiding them. The only reason I avoid writing some of them is because I know not to make them. Because I've made them. I've just failed more than you have. That's all. So this runs, it gives us 11. So now going back to what I was saying, if you divide a number by 10, let's make this shorter. Let's make it 5 digits to see, to kind of show that's easier to see. So if you take 93,458 divided by 10, it just chops off the 8 at the end. So you can think of dividing by 10 as chopping off the rightmost digit. Make sense to everybody? This is kind of a very useful technique here. Which will lead us to our last problem, because I'm running out of time. Yes, so we're going to skip this one and just do the Batman problem. Riddler. So this came from Savage's textbook in Java, and I am just simply stealing it here. So there's the credit given to the author of that textbook. Holy Digits Batman. The Riddler is planning his next caper on Pennsylvania Avenue. In his usual sporting fashion, he has left the address in the form of a puzzle. A lot of these villains, I feel, just really need some really good therapy. The address on Pennsylvania is a 4-digit number with all the following properties. So we're looking for an address. It's a 4-digit address. Sorry. The address on Pennsylvania is a 4-digit number with the following properties. Blah, blah, blah. Write a function that uses loops or loops to return the address where the Riddler plans to strike. So what are these 4 properties we're looking for? All 4 digits are different. The digit in the thousands place is 3 times the digit in the tens place. The number is odd, and the sum of the digits is 27. So this is going to be a couple of if statements, right, to go through this. So how do we figure this out? So first off, this says printed out, so we don't have to worry about returning, because it just says printed out. Def. Riddler. Riddler. It's not going to take in anything because it's just going to run the same way every single time. Right? These functions were to test various things that we would throw into it. This doesn't need anything to test. It just needs to iterate through all the possibilities. So the numbers are 4-digit number with the following properties. All 4 digits are different. It's a 4-digit number. So what are all the 4-digit numbers? For n in range. And so we're going to test all of the 4-digit numbers, which are 1,000 to 9999. So 1,000 to 10,000, because we're going to test 9999. First step is which these are, can we try? All 4 digits are different. Digits in thousands place. Normally I would go through in order on each of these, but I'm going to start by going through the ones that are simplest to solve, or go through it just simply with this first one. The number is odd. Now we can test that by using an if statement, right? That's one valid way to do that. We could use an if statement just like we used here, except to check if it's odd, you ask if there's a remainder versus if they're not a remainder. The other thing we can do is take advantage of the way the range function works, right? We can just simply say, well, I know that it's not going to start at 1,000. It's going to start at 1,001 because it's an odd, the address we're looking for is an odd number, right? And if I want to test only odd numbers, I can use that third variable in the range function that says, hey, let's go up by 2s. So this will test 1,001, 1,003, 1,005, so on and so forth, right? And what? So, so far, so with this, we have removed half of the possibilities here, right? So while that's going on, let's look at the next one. All 4 digits are different. All right, so in order to test that, we have to extract all 4 digits independently, right, and test if they're different. So that's a bit of a hassle, but it's totally doable, right? So it's a 4-digit number, so there's 4 different digits. There's the ones place, there's the tens place, there's the hundreds place, which I'm just going to call huns because I had a thing going here with 4 letters, and I'm going to keep it being a thing. And then the thousands place, thou. Right? It just looks nicer. So anyway, the ones place, we're talking about how to do that. The ones place is the rightmost digit, and to get the rightmost digit of a number, we mod by 10. Make sense? So we could say, hey, n, the ones place is n mod 10 to get the rightmost digit there. To get the tens place, we're going to start being a bit selective about this, which is that we could, well, let me kind of show you the thousandths place to kind of give you the idea. To get the thousandths place of a 4-digit number, right, if I've got 1, 2, 3, 4, if I want to grab that 1 out of there, I can divide by 1,000. Integer division, right? Because dividing by 1,000 means get rid of the 3 left digits, if you think about it for a second. Whoops. What just happened there? I had something highlighted, and then I pressed enter. So 1, 2, 3, 4. Right? That gets us the 1 there. So n divided by 1,000 gets us that number. Right? If I was just doing regular division, 1, 2, 3, 4 divided by 1,000, it gives us 1.234. So you might test. So again, test that, and then you're like, oh, I see 1, 2, 3, 4. I see the decimal point. Right, I can get rid of the decimal points by doing integer division. Divide, divide. That's how I noted. So you can see how you can go from a mistake, test that mistake, go to here. Okay, tens place. So what we can do here is kind of combine these things. Okay. So the first thing we wanted, so to get the tens place, if I got rid of the 4, so if I got 1, 2, 3, 4, if I got rid of the 4, I could then mod by 10, right, to get the rightmost digit. Make sense? If I got rid of the 1's place, I could then mod by 10 and get that rightmost digit, which would be the 10th place. Modding, right, dividing by 10 to get rid of that, then modding it. So we could write something like this. N divide by 10 to get rid of the, what would that do? 1, 2, 3, 4, divide by 10, gets us that. And then 1, 2, 3, mod 10 gets us last digit. So, what order, and of course you might end up with something that looks like this. N divided by 10 mod 10. And that looks terrible even though it's mathematically sound. Why does it look terrible? Because you see these symbols and you're like, which one goes first? And the answer is these are on the same level in PEMDAS, so it goes left to right. But a lot of times you don't want to think about PEMDAS. So what should you do if you don't want to think about it and try to remember those things? Make it easy for you. Just simply discard the issue altogether because you know the P in PEMDAS means parentheses, so let's use parentheses. Make sense? Similarly, and just to speed things up, similarly, for the hundreds place, we can do n divided by 100, right? 1, 2, 3, 4, divide by 100, which will get rid of the 3 and the 4, and then we mod by 10 to get the 2. So now we have to ask ourselves, how are these all different? Well, we know how to test if two things are equal. You can also test if they're not equal by doing so. Like this. There's other ways to test for not equals, but this is the way to do it, right? If you remember like not equals being a kind of a, right, looks like this, like with a slash through it. Can't really write a slash through on the keyboard, so we kind of tried the next best thing, which is this. Whoops. Not equals. If 1's not equal to 10, whoops, 10's, and then here, these all have to be true is what I'm saying. 1 not equal to huns, and 1's not equal to thou, and 10's not equal to huns, and 10's not equal to thous, and huns not equal to thou. Not thous, they're all 4 letters. That's how I remembered what the abbreviation should be. I remembered they were all letters. Okay, so indent this to test it. 1's. Indent it to test it. And now we're going through, and these are the cases where all the numbers are different. Okay? What I did is I checked 1's against 10's, hundreds, and thousands, and then I didn't check 10's against 1's, because if 1's is different than 10's, then 10's is different than 1's. Make sense? It's a reciprocal thing. All right, almost done here. So the next 2 steps are, the digit in the thousands place is 3 times the digits in the tens place. If thousands, the digit in thousand place is equal to 3 times the digit in the tens place. That's part of the reason why I did it like this. And then finally, so this will reduce, so here we go, this reduces that. If we run this, we get the numbers where those are true, right? 9 and 3, 6 and 2, and 3 and 1. Those are the only valid ones there. And then finally, if the sum of the digits is 27, so if 1's plus 10's plus hundreds plus thousands is equal to 27, run 9837, right? And so we've managed to, so there we go. So we've got 3 if statements. We could have made this a giant and statement, but we've already got one giant and statement, and that was already giant enough, right? Right, we could potentially break it down into more and more if statements, but at some point it gets ridiculous. And also at some point the length of this gets ridiculous. There is better way to test this, but it involves knowing about sets and stuff like that, and we don't need that. Also, it's 3:20 and we finished this one and we're good. So the way you get credit for this one is very simple. Okay? The way you get credit for this one is very simple, and I'm going to go ahead and stop recording so all you all know.